We have a lot of very fancy index methods and a lot of well, available API for that as well. But not all of them are at least building as efficiently as they can, or retain their storage in the most efficient ways. For instance, we saw that the B3 performance in size and speed significantly improved with the last like 5 versions due to deduplication and eager deletion of tuples from the tree as features in the past 5 versions, I believe. And similar things can also be applied in most of our other index methods. For instance, I am fairly certain that at least the optimistic deletion of items when we hit a situation of a page split is not yet applied to the SPGist or gist or gin or other index methods that we provide in the system. Similarly, currently only B3 and SPGist in applicable cases are pre-sorted before loading the data into the index. It is currently being worked on for hash, but for instance, gin can help. Gin index building should be able to be improved significantly if we pre-sort data. There are some issues regarding that, but it should improve the performance significantly. And lastly, we have the Brin index, which is a great index, but we don't use it in the most efficient manner that we could hit, because, for instance, we have min-max ranges in the Brin index, which we could pre-sort and then use that pre-sorted range to get a top-end sort without having to hit the whole database in blocks, because we can exclude a significant part of the blocks of the database just by having the Brin by just touching the Brin index instead of all of the blocks that are covered by the Brin index. Because we already have the range information from the Brin index instead of having to touch that, get that from the pages.
Are you looking for questions already, or are you?
Yes, I'm now looking for questions, comments, whatever. These are my notes on what can be done.
The Brin index one is interesting because my first question is that something that would require a different kind of executor plan?
Probably, yes. You would need a sort that can take into account the existence of ranges that return the tuples within that range, and have that pre-sorted and start fetching more tuples when a new range is being hit because the previous ranges were empty. So yes, there would need to be an incremental sorting method that's not incremental in key, but in tuples being fed into it in increments and tuples being pulled out of it in increments as well.
It seems like the kind of thing that might benefit from graphical illustration, because I'm not following you, yes, to be honest with you.
Yeah.
Just FYI.
Yeah.
It's difficult to verbalize these things.
Yes.
I always have something in my head that I can see, but no one else can. So it's useful if a little bit
Yes.
difficult.
Please give me a second. I'll grab my drawing tablet and give you a drawing of what I explain.
You should. I think that's a good idea.
I mean, generally, I think there's a step in the process here, which is going from an algorithm that makes sense, like outside of Postgres, and trying to figure out how does this map to, like, what part of this should be the job of the index, and does that need new index access method things, interfaces, and then what part of this can be done already in the executor or needs new types of executor node. I think
these are the questions that keep me up at night.
I think to some degree we got to a point with the executor long before I joined the project where it did almost everything we like. You could make it do anything without adding new nodes and without adding new interfaces. That it seemed like it was general. And then, but like if you look at things like index scan, there's an index scan node and it uses the index scan access. Like they're more in bed than they.
I remember, I mean, I wasn't around at the time, but I've seen before the index API was there, you kind of had, it looked a bit like the catalog access code where you're sort of, specifying quite a bit with what would ostensibly seem like an implementation detail. That was like 2002 or something. Tom put that in. The API itself, I mean.
I better start typing notes.
I know what you mean, though, because I'm reminded of discussion about what I've started to call broadly MDAM techniques. That's basically the way I say skip scan, but it recognizes that there's actually a rather large, it's a whole family of techniques, some of which we arguably or indeed do already have. And it's exactly the problem that you said of where it's, or at least something I had great difficulty with, not knowing how to conceptualize it, not knowing how to, even in an ideal world, where would I put it? Even if I had unlimited resources, conceptually, where do I place it is a hard question. And I think that's kind of just how it is to some degree.
Yes. We have something similar. Sorry, we have something similar already in the executor to deal with the sorting by distance from a point code with the gist index. I think that already is kind of similar, where you get a batch of tuples and then you sort them, and then you get the next batch of tuples, and you keep merging and adding stuff to the sort at the same time.
The KNN gist, right?
That's right. That's one. Yeah.
I actually said, I made the comparison between that and the stuff I just mentioning. I think it's kind of similar, because the reality is there is a sort order, but it's sort of, it's complicated, right? Because you're kind of building it, the distance operator thingy that you're using, you're sorting on that, right? So it's kind of, it's sort of self-similar pattern where there's an executor within the executor node to some degree or something like that, right? Does that make sense? And that seems weird at the very least. Maybe that's okay. I don't know how to judge that. It's very difficult to know. The concern is, of course, that you break something or make something harder that you didn't mean to.
But yeah, the idea is, I hope the contrast is all right, but you have a lot of block ranges indicated by
the range. Make it higher. Can't see. Can you lift it a bit? Okay.
Yeah.
Yep. That's better.
You have ranges of values, and you can sort them, and you basically start at the top, this is quite difficult. You start at the top. You find whatever is equal. You pull out the values, sort them, pull out more values, and then you reach the next range. Grab those, and you can start the range sort by sorting by the minimum value or the maximum value if you do order by reverse order or whatever.
Okay, so hang on a second. It's a Brin index, right?
Yes.
Talk to me like I'm 5 years old here.
Yes. It's a Brin index. It has a min-max for a range of blocks. So the minimum value of the ID and the maximum value of the ID in a range of, let's say, 32 blocks. And usually you use those as just for the bitmap scan. But you can also grab all the values returned from the Brin index and sort them, resort them on either the minimum value of the min-max or the maximum value of the min-max if you want to go from the top of the values list, and use those as indicators of where do we expect those tuples to be in the total sorted list, so that you can do the top end sorts without having to actually touch all the data, because you can exclude a lot of the values once you've gathered the first 500 or what the first n values from the
So what does the SQL query look like here?
Do you mind if I ask a quick question? If I'm following you, I want to see if I'm understanding what you're getting at.
Yeah.
I think if I'm following, you're effectively saying, like, if I'm just going to simplify down to 2 block ranges, because otherwise I can't talk about it out loud. But like, let's say you have a block range from 1 to 10, and you have a block range from, let's say 5 to 15. So they overlap, right? 1 to 10 and 5 to 15.
Yes.
If you order by that column ascending, then you can know for certain that you can get values 1 to 5, well, or 1 to 4 inclusive, without needing to even look at the second block.
Correct.
Because you've already guaranteed that you already know from your block range that you can't possibly be in any other blocks. Is that kind of what you're working towards?
You know what type of sorting would be ideal for this, Peter?
Well, actually, I'm out of that game now, so I don't know. I kept doing it until it started to seem hard, and then I moved on. But I didn't. They had good results with that, so I was perhaps wrong.
So, like, I mean, you could just implement the regular index scan interface in Brin this way.
Yes.
I still don't get it. What does the SQL query look like here?
Just a simple order by, like, you could have, it could be even as simple as, like, select star from foo where bar is, well, not even with a where clause, just select star from foo order by bar.
Okay.
I think would be sufficiently minimal for it if I'm following correctly.
Yes, correct.
It's a Brin index, so naturally it's going to be on some kind of clustered column.
Yes, but it doesn't strictly have to be as clustered as you'd normally have that, as long as the exclusion of other blocks is large enough, because that's basically what indexes do. They assure you that you can exclude a large set of other blocks from having to touch a large set of other blocks. And what the Brin index in this case does is provide some very high level but accurate statistic on what is not in those blocks, or what is in those blocks, but not necessarily, because.
So there's a limit on the order by then. Is that it?
Yes.
You didn't mention that part.
Well, it can be. It doesn't have to be, because the sorting operation is greatly more efficient, I assume at least, when the data is at least in some form pre-sort, some amount of pre-sort.
I mean,
That could be, yeah.
Peter, I mean, I think he was approaching it from the point of view of top-end sorts, but if you approached it the other way and said, like, if all you've got is a Brin index, could you do a normal index scan, ordered index scan? And it kind of seems like we should be able to do that. Like, it's
with caveats. Like,
the caveat would be you'd have a very potentially very large heap or sorted set that you still have to process, because potentially the whole table is in your work table.
It reminds me of KNN just again, as Vicky was saying earlier.
Yes, basically.
Well, reminds me of the old tuple sort the tape sort that we had.
well, this is why you were saying that you need a sort that can allow you to pull tuples out right as you go, which is actually something, as a side note, that I wish we had when I was working on incremental sort. Like, it would make something that you could pull tuples out without finalizing the sort would be nice in other cases also.
You mean something that did that reliably, even when you didn't spill to disk, basically.
Right.
Where you had some notion of
like a sorted tuple store, effectively. I mean, for lack of a better.
Well, isn't that kind of what it really is already? It's just that in practice, the degree to which it is varies too much. In principle, it is already that, though, is it not?
Yeah, it's just that the API doesn't give you any clean way. Like, it's not.
Right.
It is.
My point is, it's essentially a hint, right, about the access patterns and nothing else.
Yeah.
Or it could be not that way, at least, if I'm not mistaken, if I get it.
Just FYI, the notes are not going to be very complete. I'm not able to keep up with you guys.
Don't worry about it. I think it would be really rather unfair to expect. It's very rapid fire. So
I didn't really expect the Brin thing to be like, I don't know how to put this, like a top level. I don't know.
These streams are being saved, by the way, or?
Okay, Matthias, keep going.
Yes.
What's the next one on the list? Because you said you had a list, right?
Yes. Well, this was basically.
Can you go through them quickly? Can you go through them quickly and we'll triage? How about that? Just go through them, try to summarize them, and then we'll go.
My next point was building a range index on top of the Brin min maxes, like we do with just using the range operators there. That would allow us to pinpoint, for instance, IDs to.
Can you repeat this?
Yes. Building a Brin-like index, a range index, on top of the Brin min maxes. The main benefit for this would be that you'd have orders of magnitude smaller index size, while still maintaining some amount of accuracy in your index results, without having to go through the whole table.
Do you mean you would build a tree structure on top of the current Brin index?
Yes.
Okay.
Because currently
wouldn't that make it larger, not smaller?
Well, yes, it would make it larger than the Brin index itself, but the gist index, gist index-like structure that you build on top of it would be orders of magnitude smaller than whatever your other index would be, because you only have to build an index on the summary of those whole pages instead of the hundreds of tuples that are inside of those. So that would save a lot of space.
I think I remember this one from a conversation of ours previously.
Yeah, this almost seems like how you would have built Brin in the first place if it weren't so sort of targeted towards being a very small, dense representation. Like, if you wanted to do something like Brin as a fully general, could handle any data model, any data distribution, you would probably start that way.
Yes, and also no. Brin is quite good at being built on already clustered data right now, and is built for bitmap searches, which is totally fine, and I totally support that. It's just that this is another feature that can be built on top of that is just not implemented yet. You don't have to build prefix or suffix truncation into B-trees just to have a B-tree that works. Same for Brin here. It's just that we can add much more fancy features or save a lot of space if you don't need the specific accuracy that the other indexes provide.
So what would you use this just tree for?
For low accuracy but still important filters. Basically for analytical queries.
So right now, we just scan the whole Brin index for ranges that we're interested in. Would this just be an optimization to find the Brin ranges that are relevant more quickly?
Yes.
Okay.
Yes. And would provide you with a better optimized version of that incremental sort of just a moment ago. Because you have a tree structure to walk through instead of not that tree structure to walk through. And having to do that all in memory.
Okay, so how many more are there? Just curious.
Well, I just went through SPGIST, MB3, Gin, and Hash. So this was the last one.
Okay. I
Technically.
just thought I'd ask.
What did you say about hash? I didn't see any. I didn't
Okay.
catch it.
We can do the same optimization as is implemented in B-tree. That is optimistic deletion of items when approaching page splits or bucket splits or whatever. And the
You should just if you go do that, I'll commit it. Just do that for hash, do that for gist. I will definitely commit those because it's actually not that. It's kind of easy, and is also. Maybe it'll be a little bit different. Obviously, I can't absolutely promise it, but intuitively, the principle is exactly the same, right? So why wouldn't it just? So that I mean, you could probably just do that, and it'll be okay.
Yeah, and the pre-sorted index build for hash as well, but that's being worked on right now. So not amazing.
The basic idea that I think it's very easy to sell is, so the way that if you look in detail, as Postgres 14, the traditional way that we do index deletion is still there and it still matters, namely the LP dead marked index double deletion, which I have sort of renamed simple index double deletion to distinguish it from bottom up deletion. That it's doing more than it used to, though, in that it includes what I call extra index tuples that happen to be cheap to check in passing. So mechanisms by which we get an XID to include in the WAL record for purposes of generating a recovery conflict and not standby. We're already going to the heap again a second time in order to just get that value. So it's quite easy to, at that juncture, say, oh, while I'm here, why don't I check anything else that happened to be in the index but not yet marked LP dead? And if and only if those two are also deletable, then I will ultimately delete more than I'd initially set out to. So it'll be almost as if they were LP dead marked in the first place, even though they weren't. So that's what we do in NB3. Greg, I feel like
I don't know what to type.
Like the point is we're batching. It's a batch thing, right? Like we're already going to the heap anyway to get that information because we have to. We need the XID. Why not go check stuff that there's a natural tendency for them to be clustering, right? So why wouldn't we, while we're there, check other stuff that we don't know for sure is LP dead marked, but it's so cheap to check, there's no downside.
Is this being done in B-tree because it's like naturally part of the way B-tree works, or should this be some more general
Well, that's what I'm saying. It should be more general. It's very general principle that.
But what
least
I'm
in
wondering
Postgres-
is there a reason why this has to be copy pasted into each index access method? Should there be some heap AM
There's only
function
one
or something that's
There's only one small reason, which is B-tree has a different representation for posting list tuples now. But other than that, no. Other than that, it could be. In fact, this patch would be totally generic. You could, because it just so happens that hash indexes and gist indexes use exactly the same index tuple representation in exactly the same way as far as any of this stuff goes, at least. That would actually be totally generic. It already is totally generic. So it's in some generic C file. I think it's in index.c or something. So that would continue to be the case. So you're right that it is very generic. The only tricky thing for a B-tree is that you have the posting lists as well. You don't want to miss those. That's just a small detail.
But like, is there some way to structure this so that every index access method gets this for free?
Any index access method that has the original sort of, so originally only B-tree had a mechanism, anything like this. That was first in 8.2, right? Where you were marking index tuples LP dead, which is sort of a way of saying, oh, they're not visible to any possible snapshot, at least on a primary. And then sometime later, when it's convenient, we have to physically delete those, typically when the page fills and there's some stuff that we know for sure is dead. We have to get rid of it permanently then. But we're
So are
lazy
you
about
saying only B-tree had LP dead originally?
originally in 8.2.
Okay.
So that's where it comes from. So if you look at the implementation in gist, hash, just those two actually, those two have something that's very exactly derived from it. So it's just not quite copy pasted, but not too far off.
Yeah.
So it's perfectly clear that yes, you could just do it in exactly the same principle would apply. You have nothing to lose here because the cost of revisiting those blocks is so much larger. Anyway, if you even have a small chance of getting something more to delete, that's bound to be worth it. The asymmetry is very, very big. So yeah, I mean, does that make sense?
I mean, I'm not sure. I think I gave my 2 cents that like maybe to look at how this could be done once, but I'm sure it makes sense.
That would be the
I'm
way
sure
you do
you
it.
understand what I'm saying.
Sure. No, okay.
I'm just not sure what to.
I was just sort of responding to. I got the impression that I didn't want to, be dismissive or anything. So I thought you were.
No, I'm following like in as best I can in the abstract. So I mean, I don't know. The notes are not very
So I have I don't want to hijack the session, but if I have another one I'd throw on the list if now is an appropriate time to.
Sure.
So I got this idea a couple of years ago and I worked on it for a little while and then stopped just because it's a lot of work. But inside of a B-tree, obvious. So if we start out with the really obvious case where we select foo from bar, order by foo, obviously the B-tree supports that ordering, right? Like this is the easy part. If then though we change it to select foo and bar from Baz, and we do we add a where clause where foo is in a list, let's say where foo is in 1, 2, and 3. And then we order by I'm looking at my notes again to make sure I'm saying this right. But just order by the second attribute. So if we select 2 attributes, the first attribute is our in clause, and we order by the second attribute. It's possible to support ordering in the B tree for that query with some different accessing methods. I don't necessarily, it may be a different AM. I don't.
So are are you familiar with scalar array op express?
Yes, right. So like effectively
Talking about, right?
Right. So you would have to rely on the SAOP, right? But like your in fact, as a side note, like the SAOP stuff and optimization on that was my like gateway drug into Postgres hacking, but and first patch. So I have fondness for that area. But
can you sorry. The original select is select where foo equals something order by bar.
let me drop.
I mean, I think I know what you're getting at. So
let me drop something into the chat real quick. Not using foo and bar, but if you have something like that, so and I see it misspelling it already, but like so you have a foreign key in with an SAOP, and then you also say that like a created at timestamp column, and then you order by just the timestamp column. You can, with the right code in B-tree, you can actually make that orderable by
and
the
B-tree is on just created at?
No, the B-tree is on both columns.
In which order?
In owner FK and then created at.
Isn't this just kind of an example of skip scan?
Not exactly.
No, it's like cycling. I was trying to come up. I called it like a cycling prefix.
It's kind of both in this case.
But if you kind of skipped through the B tree, based on if you first sorted the owner FK and then kind of did a merge sort with skip scan, right?
Well, the thing is, the thing where it's no longer like the thing where it's no longer like skip scan is that you have to be able to cycle back. Like if that prefix column is like 1, 2, and 3, basically what you want to do is be able to pull the top created at value from the first prefix, if you will, that owner FK column, and then the next one and the third one, take the minimum of that and keep going on it until you get right, and then you keep looping around to keep pulling rows. So like you're pulling rows from different paths down the B tree, but going back and forth between those paths.
So you could write this SQL now as a union.
Well, you can write it as a recursive CTE.
No, but even just a regular union, like where owner FK is one of them and created at less than, and union all union, and then an outer.
Yes, but then you don't get the benefit.
Match.
Like if you write it as a union and not a recursive CTE, then what you don't get is the benefits of then adding a limit onto this. Like the real key is when you add a limit onto this.
I think you would, because you'd get a merge append. If you could arrange it to get a merge append, it would the limit would work.
So this is why I feel the framework, if you like, that the MDAM paper provides will prove useful, because it's very easy to talk at cross purposes about this stuff. Like there's all these different distinctions. Even the basic use of phrases like skip scan versus loose index scan is totally ambiguous. I think that an interesting distinction here is the MDAM paper makes pains to point out. So, Greg, you might have been thinking of that patch that Tom had in 2019 that didn't go anywhere. Jim Nasby reported problem. Were you thinking of that when you said that?
No, I was thinking of my own merge append patch.
Well, there was a patch that pretty much explicitly something to do with join removal that was equivalent to doing what you just described or something along those lines. And sorry, not necessarily that important. Let me just finish my point and then I'll let you talk. My point is, one of the built-in assumptions of the MDAM paper is that you don't have to do duplicate elimination. So it's kind of like really is equivalent to, from the executive point of view, it really is equivalent to an index scan that's in order. It doesn't know the difference. Because it's built into the B-tree code, as it were, there's no question of there being duplicates to eliminate, I think in almost all contexts, because however you implement it, there's there's a built-in understanding of the key space, and so you have to sort of, I think, do it that way. I think that's the way to go, rather than trying to introduce ad hoc mechanisms to do duplicate elimination. I think the reason that
I didn't hear him talking about duplicate elimination, though. He was.
Well, you said
talking about.
You said union all, didn't you? You said union or union all?
Oh, well, I mean, I was talking about how you would arrange the query so that the executor was doing the algorithm he was talking about using the merge append node. So it would have been union all actually to do it what I was trying to say. So
but that would assume that you didn't have an existing need to deduplicate.
What I find interesting here is that there's a lot of ambiguity about which parts of the algorithm should be in the index access methods and which parts can be in the executor. Like,
I'm suggesting.
I mean, I don't see how. It seems insane to imagine the planner coming up with a executor plan that would repeatedly scan. It would notice that
I don't think it would be as performant as you'd want it to be anyways. Like just like the SAOP stuff is an optimization inside the B-tree code itself. I think that the only way this really makes sense, I'm not, assuming it makes sense, right? The only way it really makes sense is inside as a B-tree optimization specifically.
It's not really true that the current code isn't clever about avoiding descending the tree multiple times.
Correct.
It could be, it isn't.
But to make this performant, it would have to affect it. I mean, I think that to really get the benefits of it, you would want to effectively pin multiple pages. Like you would want to be looking at multiple ones at the same time rather than descending from the top for every tuple.
Right. That's exactly what I was trying to say, not very successfully a moment ago. Basically, B-tree code has page at a time processing, leaf page at a time processing, which I think is very important actually. And I would really not want to break that. So the idea of preserving it as conceptually an index scan that has that same property and doesn't require any post-processing, maybe you're doing something like remembering separator keys that separate different pages, leaf pages, as the scan progresses. But it does actually make sense for it to live in the B-tree code for reasons that are, if you mechanically sensible, right? You can do it that way if you sort of structure it as something that essentially lives in the B-tree code. And to my surprise, Tom, I don't want to put words in his mouth, but I believe he more or less said the same thing himself. And that's, I was unsure of it because it sounded wrong, but I believe that he ultimately concluded that a significant amount of that was in order in his own remarks on it not too long ago.
There's another interesting similarity here to gin indexes, because the gin index code has a lot of this machinery as well. I mean, if you do a gin query with foo and b and var and whatnot, it internally opens multiple scans of the same index, and then there's a lot of logic inside to do like skip scans and merge those results and stuff. So actually, something I've been saying to various people over the years is that we should get rid of gin and just replace it with the B-tree index, because gin index is just a very optimized B-tree happens to be very good at storing duplicates. But like it has a lot of
isn't it like a collection of B trees though?
Yeah. But it's basically the same thing. It just happens to be heavily optimized for duplicates. But that's
the inner B trees are the same thing.
Well, I mean, if you take a higher level enough view, it has the similar characteristics, similar performance characteristics as just a B tree.
In my opinion, the fact that it is multiple B trees in the way that it is silly. Honestly,
right?
It's sort of like wheels within wheels. What are you doing? Yeah. Just have one B-tree. But I mean, not that
it's only one.
No,
they are fixed by attribute number, but they are one B-tree according to the talks. Last time I checked.
No, if you usually it starts out that way, but if you have a great deal of duplicates, so many that you can't even fit the compressed representation on one entry tree page, then you create a whole new.
Yes.
And
Yes.
key
the
space
po-
these other posting trees they're called is basically it's not the same data type as the main entry tree. It's heap-tid item pointer. So that's kind of weird, I think. Anyway, not important.
Sorry, I didn't mean to interrupt.
I'm
So
done
you
anyway.
say
So
I guess I was stuck on. My brain was still trying to wrap my head around what Heikki was saying. So I'm picturing it as a collection of B trees with a B tree of joining them all together. But you're saying it's basically the same as one B tree with a leading column that the upper B tree is indexing, and then following
you're not wrong.
columns.
When you say that,
right, you're correct. I mean, it is a collection of B
Ah.
trees, but if you think about it, why would you do it that way? A B tree is perfectly fine with just having a fixed depth, and that works great. And so you might as well have a single B tree, and it would have the same characteristics.
I mean, now that I'm not sure what we have now, but now that Peter's done some optimizations for, I'm not sure whether we have leading prefix elimination or suffix or what, but like eliminating the common prefixes would be the key to making
we
it.
don't have that. No, that's.
Oh, okay.
I think it's quite a lot harder actually than anything that I've done at least.
So quite hard.
Yeah, I mean pretty hard. Like
the B tree code isn't quite there yet. It's not quite as efficient as the gene index yet. But I mean, there's no particular reason it couldn't be. There's no reason we couldn't optimize it to be just as good at storing these duplicates as gene.
Well, here's my observation about. Sorry, I'll finish the point. Excuse me. You didn't mention the fact that gin only supports lossy index scans, and it gets away with murder for that reason. You know that, right?
Yeah, well.
Just a real quick point. We are coming up on the technical end. I don't have any problem with us continuing, but we've only got about 15 minutes left. So if there were any particular points or questions or anything that I think it was Maria that started this, but just wanted to raise that as just so folks know we're coming up on 15 minutes in terms of remaining time.
With the gene index, kind of the reason I brought that up is that it already does a lot of this skip scan stuff. So like we already have a precedent there where the access method is responsible for doing many of these tricks, and it would be nice if we could lift them out of the gene index code into the general executor and allow us to do those tricks with any query really.
It does seem a little different for the reason I just said, but also because it sort of isn't the same kind of index scan by being lossy, even from the executor point of view. Right? So you both don't have to worry about having have race conditions where, for example, you read the pending list and then it concurrently is merged with the entry, and then you see it like that. Just implicitly is not a problem for one. And for another, you don't have to worry about like precisely navigating the tree. You can be sort of sloppy, and I suspect we lean on that very heavily, even more than is obvious. I mean, the consensus seems to be anyway that it actually does make sense for what would have seemed before to be the wrong amount, a fairly large amount of this logic to live in the B tree code for MDAM type things, skip scan, etc. Just because that's kind of the only place you can do some of it.
I mean, the only thing I'm afraid of with having these tricks in the index access method is that it seems like there would be a lot of different queries where they could be useful, and they might not all. I mean, I guess you could phrase it. You could you could pose the question in either direction. Like the planner should be able to recognize the pattern and then use the index access method that implements it, instead of saying that the planner should be responsible for constructing a plan that does
I think the costing
the thing.
The costing of this is the main sort of difficulty in the planner, more than just modeling. Because remember, in practice, skip scan relies on the fact that, so whether or not you skip is of course dependent on the actual distribution of values, which, so if it was necessary for the planner to know well ahead of time exactly how much IO you would ultimately have to do, that probably just wouldn't work. Fortunately, it usually isn't necessary for it to know with any amount of precision. So we could probably have, I mean, one can imagine many scenarios in which it's either you do a skip scan, which is with some degree of confidence likely to be faster than a sequential scan. By how much we can't quite say. Like you can get away with a lot, I suppose, just because it's either you do a sequential scan or this. And what are the chances of this being slower? Well, you'd have to be rather unlucky. So you can only have you could get away with, I guess, only having a very approximate idea of how much work you're going to have to do, because it's so tied to what actually exists in the data structure. And it's
Although
very
I have definitely seen what I like to call scans disguised as index scans many times, and they are painful.
I'm sure that's true. I'm just, my point is only that, you know, if you have, it's very difficult to, I would imagine at least, very difficult to get something like a selectivity estimate that's very accurate for something like a skip scan, but maybe that mostly doesn't matter. So it feels like there was an awful lot of confusion for a while, I think, about how do you do the planner stuff, but maybe the answer is legitimately you kind of have to rely on the fact that it would be very difficult to characterize the cost using statistics, but which, as it turns out, maybe doesn't matter as much as you'd think. But that's an intuition. I could be wrong. That's my feeling. I don't know if anyone wants to disagree with me.
I mean, in the example given, where I guess the example is generic. It just says where owner FK equals any or in. I was picturing that to be an explicit in list with like some constants. In that example, it would be easier for the planner to be doing the costing, because it would be able to go and get statistics for each of those constants. If it treats it as a like an index access method thing where it's just some opaque array that I'm going to pass the index. I mean, I guess it could still look at statistics, but if it's a general implementation where it's not really the planner is not directly involved in the whole skip scanning thing, and it's just something the index does, then it can't really. I mean, it can in that case.
It's probably both and, right? Like I mean, obviously you're going to get better statistics and better costing if you have a constant list. But that doesn't mean you want to avoid doing it when you don't. If
it's like a subquery or something, then like I think this is difficult to cost regardless of how it's implemented. Like I don't see the implementation really making the difficulty in the costing. The costing is
I think it's a good example though of where I'm not super worried about costing with it, because in the cases where this is particularly useful, it's useful because you have a limit, and you can get away with a lot when your limit is, you know, a sufficiently small percentage of the total number of rows you would otherwise scan, right? So if your limit is 50 and you know that you've got at least 1 million, or you know you're very likely to have at least 1 million rows, then like your costing doesn't need to be all that accurate at that point, because you can overestimate the cost pretty dramatically for this type of scan to prevent it from being overused, but still use it in the queries where it's obviously helpful.
That goes wrong either way, right? Like if the
It
limit,
does, but
I mean, planning is hard. Costing is hard.
I mean, I'm no expert, but it's one of those areas where I think extreme intellectual modesty is probably a good idea, even more than most things.
Yeah, I mean, it would be a bad plan if that in list actually contains 1 million rows or 1 million different values. And in fact, if that in list contains all values in the table except one or something silly like that, then you would be better off just doing a regular scan and a sort that we do today, rather than open 1 million different scans of the index.
And the thing with the limit is, it would still be a bad plan in that case if the first 999,000 of them produce no matching records.
Well, so there is a different way to. So the interesting thing about this is there's actually a totally different way to execute this than what we've been talking about so far. That is more bounded in terms of like it's more guaranteed that it doesn't do the worst possible thing, but it is far worse than the best possible thing. And that is what you can do instead is grab all of the, just like if your limit is 50, you can grab the first 50 rows for each one and then skip to the next one, right? And then just sort all of those rows and take the top 50. And that is still far better than looking at 1 billion rows or whatever. But it's, and it works even with a very large number of prefix values. However, it is still like if you have, if your list is 1 million, then you're going to look at 50 million rows when you really only want 50 at the end. So it's like, it's a more middle of the road kind of approach. It's nowhere near as impressive in the best case, but it's safer in terms of not opening up, 1 million separate scans kind of thing.
You should have led with that. That sounds compelling to me.
So I've had a hard time deciding which between the two, because like I said, the thing is it's not anywhere near as compelling for the, like, even if you take it down for 1 million entries, if you have 1,000 entries in your in list, which is where the kind of queries that spawned this idea for me, like looking at real world queries with 1,000 foreign keys in the in clause in a constant array. And then you have a limit 50, pulling 50,000 rows and sorting them is fairly expensive when in practice you wouldn't need to do anywhere near that many with the like separate descent kind of style. And so it is compelling, and also there's hard trade-offs to decide what's the right trade-off.
I have an attraction to anything that has that sort of heads I win, tails you lose quality to it. I guess like delaying things to runtime to some. Of course, it's not practical to do it in any general way, but if you can, I think that's a very very compelling thing to do, to have things underspecified in order that you can recover if something goes very wrong. So I do think that's important in general, at least.
So this makes me ask again whether this is something the planner should be doing rather than the access method, because the planner is making those kinds of decisions all the time, costing, like looking at statistics and trying to predict which of these things is going to come out ahead.
Right, but it's going to be wrong. Not necessarily very often, but when
but it can be spectacularly wrong.
Right. It's a question of exposure, is it not?
But,
right.
But at least it could have tried to get it right.
Right. I mean, the point is the planner intrinsically is using statistics. It's actually amazing. I sometimes say that it works as well as it does. It really has no business working as well as it does. I think if you think about it that way, it can make a lot more sense. So like not committing to something until the very last minute or the very last second in order that you can have the lowest possible exposure to. An example of this might be you have in SQL Server, you've got something called hash join with role reversal, where you can flip the join order dynamically. Or Hellerstein has a paper, he calls them eddies, where you kind of like rewrite the executor plan tree and on the fly. Basically, the idea is, oh crap, it didn't, there's a selectivity misestimate, so I'll do something somewhat different. I think that's like compelling. I think that's a good and interesting area for us.
I've thought about like that kind of recovery perspective. Like what's really obviously quite hard in the current design is to have a full out, like change the actual type of the node that's executing, right? Like in fact, replacing the entire subtree of the plan is impossible. But in the very limited example of this particular type of scan, it's a little easier to imagine it working where you could say, always put a sort node on top of it, like, or an incremental sort node on top of it, always, even when it may not be strictly necessary. And then in the B-tree scan, you could have some kind of cap of like, okay, I've hit too many like concurrent scans in the tree, and just start doing a regular scan through the tree instead of the cyclic approach, and feed them all into the fall back to just feeding all the matching tuples into the sort node that's above it and let it figure it out, which bounds your, it means you can get a slow result at the end, but it's no slower than you would get today, right? And it would limit your like memory exposure to a really bad scenario where you have just way more entries than you expect.
Yeah, it's difficult to know where to draw the line because, of course, there's sort of, you have to, there's some sort of deep philosophical question, the epistemology of it, like when is it gullible to, and I don't think there's any clear answer to those questions. So I would probably in practice tend to confine myself to cases where it's like, do you believe in Santa Claus? That level.
I'm not putting this in the notes.
Yeah. like that level of course, that like there's absolutely no way that this could be correct. Like that sort of asymmetry might be necessary to justify it. You know what I mean? Like it might just be that there's a bunch of special cases. I'm reminded of Robert Haas. He wrote an email about following his talk at CMU about a year ago. It was pointed out to him actually, and he brought to everyone else's attention that Postgres, the planner, on principle, will allow you to do nested loop join with an inner sequential scan. And theoretically, that's all good and fine. But if you actually look at it pragmatically, like, you have so little to lose and so little to gain and so much to lose. So if you completely ignore, if you 100% ignore that probabilistic exposure sort of way of looking at the world, I mean, I don't know where you draw the line, but it seems like you don't draw the line at never do that ever, because there are at least some cases where that's just completely unreasonable. I would argue this is one of them, because you have so little to gain by not making it a hash join instead, is the observation. So in principle, there's nothing wrong with the decision to use such a plan, because that's what the statistics say will work. But because given you've got so much to lose and so little to gain, you'd be kind of crazy to actually make that decision. And yet we do without any concern whatsoever for this. So I don't know where you draw the line. It's a very muddy sort of area by its very nature. But
I mean, I'm not 100% convinced that so little to gain and so much to lose, or vice versa, whatever it is, because you see people all the time on I don't see them recently, but back when I read PGCon General, you saw people all the time coming up with this argument that, like, why would you ever do a sequential scan? There's an index, just use it. It's there's so little to gain by using the sequential scan. And then you can construct a query where the index scan is many orders of magnitude, or you can construct joins where the inside, like you're doing.
I know what you mean, and that's
okay,
what I'm
good.
saying.
I'm not saying it very well.
I know, like I get it, I do, and that's why I say what I said was kind of very tentative. Like I don't know where you draw the line.
Mhm.
All I'm saying is, hey, look at this one case. In fact,
Yeah.
if you look into it, I don't think you can come up with something. If you can, let me know. I don't think you actually can shoot that down if you look at it in detail. I think it really is like that. And yes, is it a special case? Sure, no question, but it's relevant. So of course there will be cases where there's a lot of uncertainty about it, and for that reason alone, the answer is don't do it. But maybe there's one or two cases where it really, the asymmetry is really there, and it's not imaginary; it's real. You could, and even a very, very adversarial mindset cannot produce an example of this really losing. Like that could exist, and I think does exist in one or two places at least.
I keep going back to the planner. What would a user see if they ran explain? Would they rather see would it yeah. Would they rather see the top end sort visible, followed by the scan on specific keys with a merge append, or would they rather just see like skip scan, here's the key, and they don't know whether it's skipping or not, or what it's doing inside, because it's all happening
Well,
under
if
the hood.
it's explained, we don't know either. It would have to be explain analyzed, right?
Well, it depends.
Well, we wouldn't, or at least I would suggest that we have very little idea as to how much,
I guess that's what I'm saying, though. Like maybe
Yeah.
I'm just asking the question that, and I guess I'm in the minority to even think this is feasible, but we do most of the algorithmic planning, the algorithmic query execution in the executor, so that it's visible and it can be costed, and it can be compared with other ways of doing the same plan, same query. I'm just a little bit leery about hiding some things that look a lot like query planning inside the index access method, where it's kind of not visible, and it's like we were saying, like you can do skip scan on B-tree, or you might be able to do it on other indexes that also provide ordered sets.
I tend to doubt that, actually, even though I don't think you could do it with GIST, in fact. A lot of things you like that are sort of like that, you probably could, but I don't think that particular, because
we were just talking about doing it on Brin, though. Or
yeah, I guess that I wasn't connecting those two things.
I'm kind of equating merge append with skip scan, which is, there's kind of the same and kind of different, but
I tend to think of them as quite different, because the fact that you don't need any duplicate illumination for not quite skip scan, but MDAM techniques in general, the broad category that encompasses, among other things, skip scan. The fact that you don't have duplicate elimination is, to me at least, part of the definition of that category of thing. Like, and to some degree that justifies the way that it kind of lives in the B-tree code. There probably would be some planning. You probably would require some callback into the B-tree code for the planner also, which is not there at the moment. So it wouldn't be like you'd be completely ignoring the planner. Yeah, I don't honestly though, I don't know. I'm guessing, I think you'd have to sort of try it out and see. It's a very interesting paper, if a little challenging though, the MDAM, because it's sort of like, what if we could, because it kind of breaks your head to think about it, because it is suggesting ways in which a query can be executed that seem very alien as a Postgres person, but like it's totally doable. And it's doable in a way that is sort of semantically tractable. Like, you don't have to sort of do nasty things to make it work. Like, again, doing your own duplicate elimination. I think that's what MySQL does for its select distinct thing, what people call, I think, what they call loose index scan. I think that they have difficulty making it work that way. So they can only do it with duplicate elimination. They can't not do duplicate elimination. That's just, they don't have an access path that does something like that without there being duplicate elimination as part of it. The queries that they can do, they support intrinsically are only like select distinct.
Okay, I'm going to try and add these notes to the wiki, and spend the next 10 minutes putting bullet points into the wiki.
On the question of
now we're about 10 minutes past, but I mean, I'm happy to let things continue on, and I will throw it to Dan for when he wants to kind of cap things off overall. But
you guys go as long as you want. I got lots to do.
All right, sounds good.
So on the question of whether this should be visible on Explain, I want to point out that we already kind of do this in the gin index, and it's not visible in the Explain plan.
And it's not, and that's a bad thing, isn't it?
I think it's a bad thing. I agree.
Yeah.
I was going to say that. I don't think we've heard users complaining though. But while actually working on those features, it would have been really, really nice to see some more output in the Explain for that.
That feels different to me, because with Gin, the thing that you're indexing isn't the thing that the user is indexing. In other words, the entry tree is not a B tree on an array of integers. It's a B tree on integers. So the fact that there's kind of a self-similar inner world is maybe more natural, because whereas here with the what I keep calling MDAM stuff, I'm very particular on that point. It's more like, I'll take it from here. These things are quite naturally more the kinds of things you would think would be visible to the planner. So it seems like there's more of a dilemma there, because it's.
I don't know. To the user, if the user gives a query where text column contains foo and bar and something else, or something else, and there can be Boolean operators in that query, like within the gin, what's it called, gin query, the full text search query thing. I mean, how is that different from having and or clauses in the original SQL query? It's not that different.
Well, maybe it isn't, and maybe it's just. I'm just saying it appears to be and feels a little icky. I don't know though, but basically the thing that Tom, again, I don't want to put words in his mouth, but as I recall it anyway, sort of said. Don't change very much at all about the planner except the costing. So the planner only knows about it to the extent it needs to understand that this is not a completely ridiculous plan that's a full index scan. I think that's basically Tom himself has, correct me if I'm wrong, if he's listening, or anyone else for that matter, but I feel like.
No, that was the gist of it.
What's that?
Yeah, that was the gist of it. That we had to change the skip scan to costing-based model.
Right. That it was almost a virtue, in fact, that the planner didn't particularly understand what was going on, except to the extent that it had to understand the cost wasn't absurdly high, because in fact there wasn't all this extra, it was doing a full scan. Which I was a little surprised by, but because it sounds like the kind of thing, it's again, it just doesn't sound correct, even whether or not it is. It sounds wrong.
I have a quick question on some of this, just like the really low-level practical thing. Is there a good rule for how to think about how many pages it's okay to have pinned inside of the B-tree code?
Well, I would question why. I don't think you should have to. B-tree code has a very different. A pin signifies remarkably little in the B-tree code compared to, say, like if you hold a pin on a B-tree leaf page, I mean, I could give you all the details off the top of my head, but it's not the same as in HeapAF, where it's protecting you from a concurrent prune operation, and you can reasonably expect to, just by holding that pin, to have, like, if you have an executor slot that has a pointer to the heap tuple in a shared buffer, that will remain safe to dereference, assuming that you hold the pin throughout. There's a very different set of guarantees there compared to B-tree code. It really does very little of anything. It's very, and what it does do for you is not even worth going into now, because it's so esoteric, really. It's not doing much, put it that way.
So I think, if I understand then, so if you have, let's say, you have two descents down the tree at the same time, right? Because you're cycling back and forth between them. Would you want to keep a pin in like those pages all the way down on both sides, or at least at the leaf, I guess, or is it not worth doing?
It's not going to do anything for you. Or my question is, what would it do for you? Like, it's not going to, for example, the page can still split. It'll do nothing there. The only thing that can't happen, again, very, very esoteric really, is there's this thing with vacuum not being able to get back into vacuum lazy.c in order to do the second pass over the heap. There's an interlock there, but it's really not relevant to any of this, though. So for the purposes of this conversation, assume that a pin does almost nothing, or nothing at all.
Maybe
Currently, do we even hold a pin?
Like here between pins and locks, perhaps. A page lock is a whole different animal.
Right, that's my point. There is a sense in which a pin is an interesting interlock in HeapAM. I mean, like I said, it does prevent concurrent pruning that would otherwise invalidate a C pointer to heap tuple and things of that nature. But overall, that isn't generally true in index access methods. That's kind of a HeapAM thing only.
Do we even keep a pin on the leaf page in an index scan currently?
It depends. So Kevin Grittner in 9.5 had a feature where he would, typically we would drop the pin for reasons that are kind of involved, but basically boil down to it prevents us from blocking vacuum if we have a cursor, a long-lived cursor. It's sort of kind of applications very, very common. So what EDB at the time discovered was that was sufficient to, because of this interlock that I briefly talked about with NB3 vacuum, that would block vacuum completely with predictable disastrous results. So we can mostly get away with that now. So we do drop the pin. There are exceptions that are not really worth going into, but basically, yes, we drop the pin.
I'm guessing the background here is that if you have 1,000 index scans open to the same index at the same time, because you're doing this skip scan or whatever we call it, that's okay, because it doesn't mean that you hold 1,000 buffers pinned.
Why would you want to pin anything So I mean,
Well, you do
Well,
have
Because
1,000.
buffer mapping lookups are pretty expensive. I mean, there's that
okay,
reason.
okay.
You can only do
Oh.
that when you hold a pin.
Sure.
Oh, hi, Andrew.
All I'm saying is from a correctness point of view, I don't see that it's relevant at all.
Well, it allows you to not, I mean, like you have to hold, I mean, maybe I'm fair, it's been a while since I looked at this code, but like you have to hold the pin, right, to have the correctness at least of being in, or maybe it's a lock then, but to be able to know that your, like the page that you hold open is still meaningful, right, to scan against.
Yeah, so you'd have a pin when you lock it at the same time, of course, that would be essential, but typically you drop the pin immediately. Typically you just think about everything in terms of locks. There are, as I say, these exceptions where there's a difference between holding a lock and holding a pin, but those are not really relevant to this
I
conversation.
don't think that's true. That's
What do you mean?
like because the use of pins to prevent like the buffer from being replaced is a separate thing, and that is.
Well, okay, then that's what I mean. You might want to do something like this in order to have a very basic guarantee about the pin, the buffer not being evicted, but it's not going to do anything in terms of there's no like locking protocol type of thing going on with pins that is relevant to something like this. Not that I can see anyway.
Sure, but that other use is still like important. I think that was actually what the question was about.
Is that what we're saying though? I don't understand.
Well, it's maybe two things. I think it is that, and then it's, you know, if you have two descents down the tree, you want to maintain both of those as correct for some definition of correct. Like you don't want to every time you pull a tuple from, like if you're pulling a tuple from descent A and descent B back and forth, you don't want to walk down the top of the tree each time, right?
You don't. What you do, I think, is
I'm not convinced you don't, by the way.
What's
I mean,
that?
if you only, I'm not convinced walking down the top from the top of the tree, if you have 1,000 of them going on at the same time, is your biggest problem. Like maybe you just keep the last 2 or 3 in case you need them again, or even
right.
Like
that. The natural way to do it would be, yeah, I think that's probably true as well, Greg. But the natural way to do it would be kind of a generalization of what we already do, which is we process a whole leaf page at a time. And so there's no question, a scan will continue and it'll use a write link from the page at the time it was read, as opposed to a little bit later when we're going back, when we want to get to its right sibling. So we're already working off the write link as it was, not necessarily as it still is. There might have been a concurrent page split, but that's okay because we're not interested in revisiting that page. So the point here is by taking advantage of the page at a time processing of leaf pages, you know, you don't need to hold anything. I mean, not strictly anyway, not from you don't have to sort of hold your place if you do everything between leaf pages, as it were. And you can even do things like you could remember the high key, which will reliably represent, okay, this is the key space up to and including the things that I have accessed so far. And then you would do it in terms of B-tree semantics, potentially by either remembering block numbers that you from earlier on in a little bit of sort of scratch space, or perhaps by remembering high key values as you saw them earlier on. So if you remember the high key, and you can get back to a point in the key space just after that if you want to. From that, you don't sort of need to, or I would question the need anyway, to invent a new way of doing index scans to make any of this work. I mean, I'm not going to say that you should never do anything with holding onto buffer pins, but I just don't think it should have anything to do with the way that the protocol for doing the scans is in face of concurrency or anything like that. I think you can generalize what's already there quite well.
So with the high key, you're talking about descending from the top of the tree again each time, right?
No, I'm saying if you wanted to, you could you could either, the point is to think in terms of the key space, because
right, but if you keep multiple, like if you keep like 2 leaf nodes pinned, which so they can't get evicted, then like you could be reading you could read a tuple from one of those leaf pages and then from the next and go back and forth, right? Like that's the important piece of what I'm getting at.
No, it doesn't work like that. So even today, even with the single scan, you always scan the whole leaf page and you copy that into memory and you return those tuples from there.
Right, but then your right link,
go back to that same page.
But your right link is always safe at that point because you have a pin or lock.
It's just always safe.
Right, so you don't need a pin for that. That's what I was trying to ask Peter, and he said that.
You have to remember what the right link was, because it might change, and you can't use the new one because then you're going to be covering the same thing again, and you don't want to.
Right. So so if you remember the right link, you don't actually need a pin or a lock. The right link can be used safely.
The right link staying. The right link being safe is like the big magic thing from the Yao paper that like.
Yeah, that's exactly. Yeah.
So you could keep around in Scratchbase 1,000 right links, and work on them if you wanted to.
Right.
Okay.
Other things along the same lines do suggest themselves too. Like I mentioned, keeping a copy of the high key, that might work. You can. The point in any case would be to think in terms of the key space and try to preserve page-at-a-time processing, because page-at-a-time processing is key to this nice property of not requiring any duplicate elimination. We don't have to do duplicate elimination if we don't revisit the same key space. So if we're always making forward progress in terms of the key space, it doesn't matter if there's a concurrent page split or anything like that, right? That's generally how it works. So the key will be to try to extend that nice property of how it works today to this new world. Don't especially don't do something like invent a way that index scans stop at a point that isn't between pages, is the term. So everything should be, if you want to stop an index scan, or in this case, I guess some kind of subservient sort of part of an index scan, some more general or more specific category, then it would still, in any case, be stopping between pages. You would want to keep that up, right? And
you don't actually have to return tuples in that order. You just have to copy all of those pages into memory and process all of them before you move on. Like if you've copied 2 pages into your own memory, you could still pull tuples from each of them back and forth. Right. The point is you just have to finish. Yeah.
I mean, you could do that way. You could, in principle, you could copy the page and then assume that it's still like that, even though obviously it wouldn't be, provided, of course, you preserved this kind of key space-wise way of doing the scan. Or you could just there and then do the scanning that's required just for that leaf page, and then remember what you need to remember in subsidiary state that is associated with the index scan. Again, the point is to don't think in terms of physical pages, think in terms of logical key space. I think that's the big meta observation, basically, if that makes sense. Maybe it doesn't. Like it doesn't matter if you do it right. It doesn't matter if you have any kind of concurrent page split, and you can do things like you can refine the next page way later. Even like you can, as Greg said, that's kind of the cool trick that the Lehman Yao paper. Put it this way: you can basically assume that if you've got a link to a given page, could be a leaf page, you can assume that that will be valid like forever. I tend to think of it, when I was sort of getting the idea in my head initially, I would think of it in terms of like this index scan could have this link that's pointing to the leaf page for eternity, and it would still be valid. because the pages can split, but it's still going to be the same lower key space.
Right? And because vacuum is only ever going to delete, vacuum will only ever remove a page that is known to be dead to all transactions, so you don't have to worry about it getting vacuumed away either.
Yep. For the purposes of this explanation, it is true that the page deletion thing makes it complicated, but you can actually just forget about that. It doesn't matter. For the purposes, just don't even think about that, because that doesn't change it fundamentally. You can take my word for that. You forget about vacuum completely, because it doesn't matter for the basic intuition that
right.
Pages can only split; they can't merge. Of course, that's not exactly true, but let's just say it is, because it's true in spirit. You're always going to be at the left, at the lower half. It could be that there's a million page splits, but in any case, when you finally arrive at that physical page, having followed that block, if it's arbitrarily delayed, it's still going to be the same key space, maybe just a very, very fine increment of the lowest part of it. So you're fine. You can. So it's a very powerful idea once you grok it, I think. Because we don't have any interlock at all. We don't, like, when we're going between levels of the tree, we have nothing except something with vacuum that I just said to ignore, which you pretty much just ignore. So, like, you have no interlock. You don't have a pin. You've got nothing, right? There's nothing, because in any case you can do the.
So in practice, I think that actually means, though, that maintaining like 1,000 concurrent scans, if you will, memory effectively, right?
Well, not. Oh, in local memory, the tuples that you've loaded into local memory. Yeah.
Well, the whole pages potentially, but yeah.
I think the more relevant cost is, if you're doing 1,000 index scans in parallel, you're probably doing a lot of random IO jumping between those 1,000 scans.
Sure.
So you're
So you have to account for that in the costing, but
exactly.
Yeah, in any case, that, like, never fail to consider the key space thing and think of the key space. Don't think of physical blocks, think in key space. That's the main intuition generating thing, I feel like, because once you see that, you can sort of see a lot of other stuff too that follows.
I think this is why this kind of thing, anyways, is why Hickey's observation that Jin is a reimplementation of B-tree is so annoying, because, like, there's all kinds of optimizations and magic going on that I don't know if Jin has, and I don't know if, like, it would be nice to have all these optimizations in one implementation, not spread, not special purpose implementations that maybe don't have the optimizations.
That actually is really helpful. I'm realizing with those comments that I think the two different approaches that I had proposed for doing it can actually be combined, I think, because if you have, like, again, given that you're targeting like limit scenarios, if you have a sort node above, if you guarantee you always have a sort node above this type of index scan, then there's no reason you can't just load the first page at, like, for each like prefix key, you load the entire pages, you return the entire page's contents, and let the sort just figure out that it's gotten enough tuples into it that it can return.
Right. Yeah, that is sort of extending it to cooperating with it. Yeah, I think I follow you.
Because then you don't have to actually maintain then you also don't actually have to maintain. Well, actually, in that case, you don't even have to keep all of the pages in memory, only the right links, because if you've returned all the tuples, you don't have to figure out, like, from each page at a time, you don't have to figure out picking back up in the middle of a page.
Right. That's exactly right. Because even if, no matter what happens, it's still going to be the case that that's going to point to a page which will, in any possible universe, still have that. It'll still start back with the key space that you haven't yet read, and you'll still have returned whatever couple you return prior to.
How is this going to work though? Like, if you have a limit 50, and the top end, the sort above you knows that it's a top end 50 scan, and you return the first page from all of them, how are you going to find out whether it's emitted 50 and stop returning? You're going to have to do all of them. You can't. You're not going to ever find out that, okay.
Well, that's the point where somehow you would. I mean, and this is into imagination world, because there's not a mechanism that I'm aware for this, but you need some way. It's like to do that, you would need some way for the index scan node to be able to report to the node above it that it has finished a phase, if you will.
I think it's the. Oh yeah, you guess.
Right, like if you say like I've done a mathematically complete phase, then the sort node would
what you're saying is every tuple that I return after now will be. Well, no, you'd have to give it a key. You'd have to say at this point, whenever periodically you're going to return and say, I've now done all tuples below before this value.
Yeah. And that feels a bit more gross to have that kind of cooperation between the nodes.
I'm not sure, because basically what you're asking for from the node above is like this incremental sort thing. So the incremental sort needs to know like this sort of like how incremental is this? Like where am I at in the incremental sorting?
What's the max key or whatever so far? Or min key, I guess, but
the weird thing, I was expecting it to go the other way, where the node above would ask you I'm not sure what, like, are you where are you up to, or
yeah, that would work too.
But I think what you're
saying, but I don't think that
makes more sense.
I don't think that would work, because you would have to know, like, it's not sufficient to know what the it's not well, I guess that would work if you could get the min key so far.
Yeah, I think it probably makes more sense to do it in the push fashion, because if you ask the node at some random instant, it may not have a very good answer as to what the min.
Yeah, what I was actually picturing, now that I think about it, is that you would periodically ask the sort node, when you finished a phase, you would ask the sort node what's at the bottom of your heap, and if you know that that's good enough, then you could just stop returning tuples. But I think it works. It's way cleaner to do what you're talking about, where you just would periodically return something saying, and by the way, this is the max tuple right now, the max key.
Excuse me for a second. Stephen, I have to head out. You guys keep going for as long as you want, though. When I close my session, it might kill the live stream, but the live stream is not the priority here. It's you guys getting to talk. So thank you. I'll see you all tomorrow.
Thank you, Dan.
Thanks, Dan.
Yeah, thank you.
Yeah, thanks a lot.
So that being said, we don't really have a mechanism right now. Like the way the executor is structured, it pulls a tuple, but there's not really a like push meta information up from the node below you, right?
No, there doesn't have to be. I'm imagining this is just a side channel. You return a tuple, and every now and then you say, oh, by the way, the min key now is this. You can be certain that there won't be any more coming along less than that. And then the incremental sort could use that to determine if it's okay to return any tuples to its core.
But would that actually be a push, or would that be that every time the incremental sort pulls a tuple, it would also check to see if like You
Yeah.
can also ask the node if there's new information, basically, I guess.
Yeah, it'd still be demand pull as far as the plan tree is concerned.
There's other circumstances where incremental sorting could be useful. Like, I think it's worth having an interface where it'll work for the other plans, which this sounds more likely than like what I was talking about.
Can you? I'm not sure. I don't follow what you're saying there. Partially because I'm trying to take notes at the same time of what I'm learning. But
if we have I'm not so much thinking of the executor as the index access method. If there's a like return tuples, read tuples in mostly sorted order. It's like lossy ordered or something. It would return a tuple and the current high water mark key of every tuple. That's an interface that could get reused for other things. What I was picturing of like a thing that you call and like calls some other node to ask what's at the bottom of its heap, that's not like going to be a reusable. That's like very special purpose. Whereas the interface you're talking about, where there's just another index access method thing that returns tuples along with a high watermark as it goes, that's a very general purpose reusable thing. I mean, it's not general purpose for that many uses, but some I could imagine it being useful again. I mean, you could imagine cases where the SQL doesn't actually need them in sorted order. It just needs to know when it reaches a certain point. So it asks for it in mostly sorted and keeps going until it's fetched all the records it's interested in and never actually sorts the result. I'm thinking out loud. I'm sorry. I should let you guys talk.
All right.
We finally got Tom talking, so I should not stop him from continuing.
Kind of feel like we're reaching a stopping point here anyway.
yeah, that last insight that was very helpful. Thank you for that. This might move this back off of my like quasi permanently dead list of ideas, just because it seems like it's too much like effort to value ratio, but it might not be now.
Yeah, I try to keep really good notes about stuff, because sometimes there's something that makes a project very difficult, and then you return to it like 3 years later. I sort of internalize the idea that write everything down is really helpful.
I have the habit of writing everything down and then never seeing it again.
Yeah, I mean, it's not that easy.
So Simon had a habit. He used these notebooks. So he always kept notes in these notebooks, and he had like a bookshelf full of them.
It might just be that it's sort of ritualistic or something, right? There's some sense of having made a tiny bit of progress on a problem, and that maybe keeps you going. It could just be there's something about it that makes it possible to have a sense of progress and therefore to make progress. That's just my experience. Whatever. I wrote a document explaining how vacuum worked to myself, which was like very confused and then over time became less confused, partially because I became less confused and partially because vacuum got better.
When are you going to commit that? That's what I want to know. That should be a README in the source tree.
It's not for other people.
I feel like I used to understand how vacuum worked, and I've gotten more and more confused over time.
I actually need to drop off, but I appreciate the discussion. That was just super interesting and helpful.
Yeah, I hope to see you soon. Anyway.
Yeah.
Pity we couldn't do it in person. It's so close, but so far.
Yeah, it's a lot easier to continue these conversations over a beer afterwards, but.
Oh, absolutely. Yeah, I mean, it's kind of hot here today as well, so I'm kind of flagging for that reason.
All right,
Yeah,
I'll see you.
Thank you to everyone who's been able to attend this, and I think it's been a reasonably successful day of talks. It's great to see everyone again. I'm certainly excited about the prospect of finding an opportunity for us all to get together again. Hopefully, we'll be able to do that soon.
Yeah, in person soon, I hope.
Yeah, hopefully.
I'm going to try to get to Berlin. I don't know. Probably a lot of you guys will do the same.
It's my intent to be there.
I mean, it's Berlin, which is I haven't been there in over a decade now, but it's a very fun place, in my experience.
They need some more direct flights from the U.S., in my opinion. But hey, I was just in Leipzig, and there was no direct flights to that either. So you know,
Leipzig, there's no direct.
Take a train.
That's more understandable than Berlin.
Yeah, that's fair.
You could get it. Okay, I would have assumed you'd fly to Berlin and get a train from there. That's quite close, but there is an airport at Leipzig, but there's basically no direct flights to it from hardly. It's basically a freight airport almost.
Oh, I looked. So I mean, but the thing is, there's no direct to Berlin either. That's my point, right? From the East Coast to Berlin, there was nothing, right? Frankfurt was kind of like the best option, and then a 3-hour train ride from there, which wasn't bad. I liked the train ride.
Yeah, I didn't realize it was only 3 hours from Frankfurt.
Well, that's because they have real trains in Germany. They have nice fast trains. We like those trains. So, all right. Well, I mean, it sounds like we're kind of wrapped here. So, again, thank you to everyone, and good chatting with you all, and hope to see you all soon. For those of you who haven't seen, the website has been updated with a lot of notes. For anybody who was supposed to take notes and update the website, please make sure you get that opportunity to update the website. We appreciate it for everyone taking notes, and let's hope to see you all soon. Berlin, if not sooner, or somewhere else.
So New York is before Berlin. New
York is before Berlin. So if you all want to come to New York, I know somebody who might be involved in that. It would be great to see folks there.
I mean, I'm kind of curious who's. I guess no. It's quite early to say, but I don't know.
So New York is being run by PGUS, the United States Postgrad Association, in September. Mark Wong and Jonathan Cass are the ones who are formally the chairs for it. They're kind of co-chairing this year. I'm involved. Stacy's involved. So a number of folks in the PGUS board are involved in running that event. So certainly encourage everybody to consider going if you're available. And the CFP is still open for folks who want to talk. So, all right. I'll leave it at that. Bye, everyone. See you all soon.
Bye. Have a good one.
Good night.
Yeah, bye.